Hi students. So today we're discussing about solid state. In solid state we are discussing about an important topic which is most important for the competitive level. So that will be of the important topic will be efficiency of the packing in especially what? A body centered unit cell. So very important one for examination point of view is called as a body centered unit cell. Now let's look how the body centered unit cell will be there. So this is about the body center structure. Here the lattice points. So C is at the center of this one. Then the corners, 8 corners will have the lattice point. So the hydrogen, this will be the lattice points at the 8 corners. Then at the center also we have the one. So these three connected by what? So diagonal. So the three lattice points like A, C, F are going to connected by what? Diagonal. Now for this lattice, how we can find out this the efficiency of packing in this system? If you check it, the one will be called some BCC lattice points or corners. The point will be important. Then at the center of this cube also we have the lattice point. If you take this the first triangle, that will be known as called DEF triangle. So what is the first triangle? We have the one DEF. So from this DEF triangle we have the solid edge which is called as a A. Then another solid edge will be known as called as a A. But this is an imaginary diagonal. This is known as called face diagonal. Here B is equal to. So we know that the B is equal to what? So face diagonal. So which is going to call face diagonal. Now this face diagonal so can be calculated. So B square is equal to A square plus A square, that is equal to what? 2A square. The next one, if you move on to this, the second one will be known as called as a. This is about another triangle. The triangle will be going to call DFA. The according to this ADF triangle, we can have this. The C square is equal to what you can write? A square plus B square. But we know that the B square will be equal to what? 2A square. Hence, C square will be taken as called 3A square. Then the C will be equal to, let's see here from this one. So this is about the one, the 3 points connected at here is called. So the radius, the first will be called as a half radius, we can say. This will be called R. The complete radius will be known as called 2R, R. So total C will be taken as called 4R. So by this we can say C is equal to under root of 3 into A. Then the length of the body diagonal C will be taken as called 4R. So C is equal to under root of 3 into A, C is equal to 4R. Then we can write, so 4R is equal to root 3 into A. Then from this you can write this edge length A is equal to 4R by root 3. Edge length A is equal to 4R by root 3. Then from this you can calculate if edge length A is equal to 4R by root 3. Then what you can say? The total volume of the unit cell. What is the total volume of the unit cell will be? A cube. So A cube nothing but, so 4R by root 3 to the power of cube. So 4R cube means 64R to the power of cube divided by root 3 cube can be written as called 3 root 3. So root 3 cube can be written as called 3 root 3. The next one, the number of lattice points per unit cell in BCC. You know that the calculation just called as a 2 will be there. So number of lattice points. So the number of lattice points can be calculated. I think you know that. So the number of lattice points. So from corners. So how many corners? 8 corners will be there. So 8 into 1 by 8. That will be 1. Then from center. So 1 into 1. That is equal to 1. Then we can say total is equal to 1 plus 1. That is equal to 2. So by this you can say that the number of lattice points for BCC, because in BCC we have lattice points only at corners as well as called at the center. So if corners means 8 corners, we have 8 into 1 by 8 because each corner will be shared by 8 cubes. 8 into 1 by 8 take as called 1. Then from the center we can say each center will be shared by only 1 cube. So that's why you can write 1 into 1, 1. So total number of lattice points per body centered cubic system will be taken as called 2 itself. Then from this we can say the packing fraction. So what do you mean by packing fraction means it is a ratio of the volume occupied by 2. So I can write 2 lattice points by total volume of the unit cell. So here 2 into 4 by 3 pi r cube. So what you can write? So 2 into 4 by 3 pi r cube. divided by 64 r cube by 3 root 3. So which is equal to root 3 pi by 8. So this is about an important value, root 3 pi by 8. The next one, the packing efficiency will be taken as called as the volume occupied by 2 lattice point divided by total volume multiplied by a fraction of what is called 100. So it gives rise to root 3 pi by 8 into 100, that is equal to 68%. So that means here the total volume occupied by the lattice points is about 68. That means here the remaining space will be going to call empty space, or maybe going to call void. So the void space available in this will be 100 minus 68, take it as called 32. So this is about the important information which may be useful for competitive level regarding to the system of what? Body centered cubic system. Okay. So thank you.